Okay, just a very brief review, although I want to show you this one. We're not going to go through it in great detail, but this kind of left off where we were before. Find the zeros, factor, solve the equation. Okay. Well, in this case, it tells us that that is a zero. Telling us that that is a zero means that we also have this one, 1 minus 5i. If we got 1 plus 5i, we got to have 1 minus 5i. Okay. Well, anyway, here we did the division, and I don't want to go through this because we went through one very similar to it earlier. Got a zero remainder. Now we're going to do the division with that. It's conjugate. And we get this stuff. X squared equals 2. X squared plus 2 equals 0, rather. Okay? That's what this means. So we use the property of square roots, and we find that this is plus or minus square root of 2i. So we have now found the 3 roots on this problem. They are that 1 minus 5i and plus or minus 2 radical I. How did we do this? We knew this, so we knew we could do that to bring it on down. When we get it to a square, we have 3 options for solving it. We have standard factoring, if it's 3 terms. We have product of our square roots property, if there are only 2 terms. And then we have quadratic formula, once we get this equation down to an x squared. Okay, so here are the 3 factors. Okay, notice in every case we've got a minus there and a minus there. So here we got those. We got this on page 13 of your packet is an example how to multiply those 2 things together. If we were going away and I gave these and you had to find that. Gone both directions. I've given you the roots or the factors. You had to multiply them to get the equation. I've given you the equation and you had to find the roots and the factors. So we've gone both directions in the class so far. Okay, here's another one that we got an imaginary, so we also have negative 3i. Now, they did something new on this one. This is just, I'm just showing you this one, okay? Because this is really kind of like what we've done before. On this one, we don't know what that a term is in the standard form. But unless they give us some special indication, we assume it's 1. In this case, we would assume it is 1 because they don't give us any special indicators on what the value of the y-intercept is. Okay. So we just work it down. And this one, however, this problem we did in class last time. This one, they do give us a special statement. When you see this, that means the y-intercept value, because that's when all of the x's are zeros, giving you that y-intercept. So they're putting the specialty on this. After you get through multiplying this thing out, you may have to adjust it with an a term so the y-intercept is 0, or is 32 in this case. Okay, well, if we got negative 2i, we also got positive 2i. Okay, so that generates this, that generates that. And it tells us also that we have an x equals 4, which gives us the x minus 4. So there are our 3 factors. We multiply them out. And after we multiply, we first did these 2 because they're an easy conjugate. Then we distributed this and we ended up with this thing. Okay, usually I come down, this one went sideways. But here, the y-intercept is negative 16. But this says the y-intercept has to be positive 32. So what do we have to do to that number to make it this number? Multiply it by negative 2. So that means that in this case, this A has to be a negative 2. Okay, and that's the way you deal with that. I mean, they've got all kinds of special notations, but this means the y-intercept has got to be that. And if it isn't, then you got to figure out what it takes to get it. Now, there is one more follow-on step on this. Okay. And here's the work on this. All this is saying is we replaced all the x's in this thing right here with 0 to get that. Now, there's our negative 2a. Here's all the work they did to it. How much work did it take us? Not a lot, when you think about it the right way. Okay? So, we take that negative 2 and put it in front of here. And then we actually have to distribute that negative 2 for the final answer. Which of course changes the sign and the value of all of these. We now have a y-intercept of 32. Okay, so you don't have to worry about the A term unless they give you a special condition. All right, it'll be 1 unless they give you a special condition. Okay, here is a different one. Well, no, that is the same one, actually. Okay, find the degree 3 polynomial with with zeros of 1, 7, and 6. All of them are multiplicity 1. That means they're just going to be one factor instead of a squared factor. And it tells you A is 1, which basically means you don't have to worry about it. Okay? So, how do we do that? You just start on it. You start on it. First thing you want to do is you want to write the factors. Okay. So let's take these two together. X squared minus 7x minus 1x plus 7 becomes x squared minus 8x plus 7. We've still got this x minus 6 out here to multiply by, and there is a 1 out front for the a. So I distribute this x, and I get x cubed minus 8x squared plus 7x. Then I distribute the negative 6, and I get negative 6x squared minus 48 minus 48x minus 42. Combine that, x cubed minus 14x squared minus 35x minus 42. And that would be our polynomial. Since a is 1, it does not alter. Okay. Now, do you think you could do that problem without me showing you the steps? Because you're going to have to on my test. Okay. Anyone not ready for me to erase yet? Everyone okay? Okay, here's one coming from the opposite direction. Again, at some point, you're going to have to be able to do this on your own. So what are we going to look at on this thing? Well, this one doesn't actually tell you to solve it. This one only tells you to say, using that, that rational zeros theorem that we did, all of the y-intercept over the lead term stuff, okay, that P over G stuff, okay, that's all this one is asking us to do. So this problem isn't quite as terrible as it might seem on the surface. Okay, so you come up with your list. Well, we've got 10 on the end, right? So we would have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, just from the y-intercept. Now let's throw the 25 into the mix. What are the factors of 25? 1, 5, and 25. Those are the only factors of 25. So we've got to put all of these over fifths and 25ths. So here, 1/5 plus or minus 2/5 plus or minus 5/5, but 5/5 becomes 1. Okay, 5/5 becomes 1. So that one reduces. What about 10/5? 10/5 becomes 2, doesn't it? So we don't need these two. I'm going to put an R there for reduce. Okay, now we got to do the 25ths. 1 over 25. 2 over 25 plus or minus 25 reduces to 1 over 5. Right? 5 over 25 reduces to 1/5. So this one reduces. And finally, 10 over 25 reduces to 2/5, which we've already got. So we don't need that one. Now, this is kind of a format that I'm suggesting you use when it asks you that question. This is a way you can avoid accidentally skipping an answer. Okay? The way they're going to list them out on my paper is much less organized. Well, it's pretty organized, but it's much less useful. Okay, well, let's look at something here. What I'm going to show you is probably going to scare you. You're going to say WTH or something like that. Here are all of these possibilities that we have down here. And they converted them to decimal values. And so on. Like I said, that's a little scary, a little overkill. Okay, a whole lot of overkill. Okay. So anyway, I just wanted to show you the different approach. Now, totally different problem. Find polynomials of lowest degree with zeros, of -2, multiplicity 2, and positive 3, multiplicity 2, and with a y-intercept of 36. So they're putting a special condition on the A term this time. Okay, that right there puts a special condition on the A term. So I want you guys to list what you think are the factors on this one. I want you to go that far, because that's the first step. Okay. Well, we can expand this thing. To make multiplying it out easier. Okay. By the way, what degree is this equation going to be? 4th degree. Okay, so these two, we can multiply and get x squared plus 4x plus 4. These two, we can get x minus 6x plus 9. Okay, you understand how I got those numbers? Okay. Now I got to distribute this thing. I got to do a 3-way distribution. So I'm going to take this here, here, and here, which is give me x cubed 6x, excuse me, yeah, x cubed minus what? What?
That first x and the second one should be squared.
Yeah.
On the
Oh, squared, yeah, duh. Okay, minus 6x squared. Wait a minute.
oh, like in the original equation, the x minus 6x plus 9, it should be x squared minus 6x plus 9.
Oh, okay, now it makes sense. Thank you. X to the 4th. Duh. Brain lapse. Okay, so anyway, here we got x to the 4th minus 6x to the 3rd plus 9x squared. Okay, the second row, when we're doing by this one, we're gonna have 4x cubed. Minus 24x squared plus 36x. And then finally, by this one, we're going to have 4x squared minus 24x plus 36. Okay, so we got to add all this stuff up, and we get x to the fourth minus 2x cubed plus 7x squared plus 36. No. This is wrong. I just added those two. I don't know what I did. 9 from 24 leaves us 15 plus 5. Out of that, our negative 15 plus 4 gives us negative 11 x squared. Okay, here, these two give me positive 12x plus 36. Now, I've got all of this times the a term. But you know what? In this case, a already matches. So we got lucky. What is a? No, what is a? 1. 1. Because 1 times this is 36. Now, if they said 64, then we'd have had to make a 2. And one more step down there. Okay. Questions about how we did this? You will be expected to do something like this on tests. Okay, let me know when it's safe to erase. Everybody? Okay, here's one that I've got worked out for you already. Find polynomials with real coefficients and with zeros of that. If I've got that, which is right here, then I've also got that. Okay? If I've got this one, I've got that one. It also tells me that I have a zero of 0 with a multiplicity of 2. That means I've got an x squared out front. If it said multiplicity 1, I would have just had an x to the first. Okay? If it said multiplicity 3, I would have had an x cubed out here. Now, our plan here is to multiply those two things. This is kind of like this sheet you got right here. Okay? Fact is, it is that sheet. It is that sheet. Okay? Now, what did I do to these? I could have dealt with this part and regroup some stuff. I could have grouped these two minus 4i, these two minus 4 plus 4i, and used the conjugate rules, but it's real dangerous. So it's easier to just to break these down into their 3 parts here and then do a triple distribution. Here's the distribution by x. Here's the distribution by 8. Here's the distribution by negative 4i. These two happen to cancel out. Just happen to. Now, honestly, will often happen. Okay. Anyway, I add everything down. I get a total, well, to here, I get x squared plus 16. These two cancel out because I got a plus and minus of them. Here, I've got these two. And out here on the very end, I had a negative 16i squared. Okay, when I took this times that, I got this negative 16i squared, which I had to convert, making it positive 16. So this positive 16 mixes with this 64 and this 80. Okay. Anyway, it all comes out to be, or the 16 and the 64 make the 80, I should say. I misspoke that before. So I've got x squared plus 16x plus 80. Now I have to distribute this x squared that was in the front. And here is my total equation. Notice I don't have an x term and I don't have a y-intercept term. Okay. That tells me that I've got a 0 y-intercept. Well, in this thing, what value does that represent? It represents 0 with a multiplicity of 2. Okay. But I needed to show you where this 16 and that 64 made the 80 here. I'm going to go on because you've got your handout sheet if you need to copy from it instead of the board. Okay, here's another one. Degree 3, a cubic. We're going to have an x cubed on the front end. We've got an imaginary there, a complex, and we also have -4. Okay, well, we work it out. I'm just going to tell you this because we've been doing this every time, unless somebody wants to see that problem. Do I need to at least list the factors? You're okay. All right. Well, that problem becomes this. And then we were going to work it the other way. And just work it both ways. And what do we got here? Of parabolas, don't we? We got this one. Here's the x-axis. We've got points at 0, something, and something, and vertexes up here. Can we write an equation of that thing? Well, we should be able to. Okay, so here it is. I overlaid a piece of graph paper on it. So I've got 0 there, I've got 2 there, and I've got 4 there. We're going to discount this stuff that goes below the axis just for simplicity. Okay. Now, what does this mean that I'm going to have on this thing? Well, if we put it in vertex form, or if we start looking at it, because I've got a 0 at 0, then I've got an x, right? Because it has a 0 at 2, I've got an x 2. So the equation of just this one is going to be that, and I had to have an a term to make it work. Okay, because my y-intercept, or well, in this case, my y-intercept had to be 0, but I also had to have the height on that. Now, what about this equation? This one has a 0 of x is 2. This one has x equals 4. And we've got that same -3 because this thing opens downwards. It's negative. Okay. Well, let's look down here. If we look at the whole thing, we've got them at x, here, and here. Okay. And we have a multiplicity of 2 because right here I've got a touch and go point. Vertex of this is 1, 3. Vertex of that is 3, 3. Okay. So I've got these 2 maxes. Now, here we've got to have that in here. We have a multiplicity of 2. Okay. And we've got to have that 3, that -3. So there are our equations for this particular golden arches. So next time you go into McDonald's, you can say, hey, did you know that the equation of your arches? Yeah, right. And they would look like at you like, are you insane? Okay, well, anyway. First time I ever did this, and that's the total equation of this whole thing. Notice my y-intercept is 0. When I multiply these equations out. Well, anyway, the first year I did that, I talked to McDonald's, showed them what I was doing, showed them a piece of paper, which I thought I had up here, but I don't see it now. And they donated me 25 free hamburgers for my students. So I was able to pass those out, but couldn't get that this year. They only did it once. Okay, so now we're going to change gears. We're going to go into inequalities. That's the pattern we've done on everything we've done. We've done sub and solve, we've done work it out, then we've done inequalities in just about every section we've done. So that's where we're headed on this. Okay, this is just saying these are the 4 possible inequalities. Okay, that's all that says. Now, what this is saying, get a 0 on one side, and then figure out what your values are. Now, I don't teach boundary points. Okay, I'll warn you that ahead of time. But let's go on. Because I believe in looking at the above and below when you have it in standard form. Okay, now, if X is positive, then you got that, and negative, you got that, okay? Meaning negative values below 0. Positive values are bigger than 0. That's all that stuff is saying, okay? Now, let's look at this problem. Here is an equation. Here are the factors less than or equal to that, okay? Let's multiply this out. Now, let's multiply this thing out, and you get that. First, you had to take the 50 on the other side. Now, you notice they put an equal sign. Although our sign is less than or equal, you solve this as if it were n equal. Okay? So we factor that thing, and we get those 2 x values. Then we plot them. Here is the x equals 5 up here. Here is the x equals -3. We look at this to find our y-intercept. So our y-intercept is down here at -15. Okay? So we're able to graph this thing. Now the question is if we put this less than or equal back in here, what part of that graph is included and what part of that graph is excluded? Is what we're really asking in this question. What are we including? What are we excluding? So here's just a number line corresponding to the x-axis. Okay, and they just picked some random numbers that were bigger. Okay, and they're trying to show you the boundary stuff. Now, They're trying to make this a lot harder than it needs to be. Okay? If they're trying to make this harder than it needs to be, what you need to look at this is what part of this thing is included on here. Well, only that part between here and here. Okay? Because if you have this, the equation is less than or equal to zero. Okay? That means it wants to know what part of the graph is below the x-axis. That's what that means. Okay? If this equation here with that symbol says it's less than or equal to zero, then that's wanting to know what part of this thing is below the x-axis. Littler, including the two endpoints. That's what the equality does on that. Now, if you didn't have the equal under it, then these would be parentheses if you didn't have the or equal. Okay? So, that's what we're looking at on this. Do you need to do this stuff? No, you do not. Okay? Let's look at this one. Let me get rid of that. Now, solve for x. I've got a touch and go at 2. I've got a crossing point at -3. Okay? What is my y-intercept in this case? If x is 0, x is 0. -2 squared is 4 times 3 is 12. Positive 12. Or in other words, the y-intercept would be 12. Everyone understand what I just did? I found the y-intercept by replacing these with x's and multiplied, or with zeros and multiplied them out. That's where this 12 came from right here. So we've got that graph pretty well done. Now, what part of this graph, here's the question this is really asking. What part of this, the graph of this equation is above the x-axis? That's how you translate that question. What part of this equation is above, but not including the x-axis? Because this is y values bigger than 0. Okay? Well, everything from -3, but not including the -3, over to here would be included. So I would have non-inclusive -3 to +2. Okay? And then I'm going to have from here up, non-including +2 to infinity. What goes in the middle here? What is this unit? It's that 2 that is on the line, and it can't be on the line. Okay? Any questions on this one? I'll go ahead and erase my scribbles and put the rest of them back up there. Okay, they're just locating your x values. You don't need to do this test crap on stuff. Okay. Let's go to a different one. Here, you got these two factors less than 21. We move the 21 over the other side. We multiply and we distribute that and bring over the x and the -21. Simplify this thing. And ultimately it factors into this, giving us these two values. Okay, everybody with me so far? Heads nodding, yeah, okay. So we plot 7/2, which is really 3.5. Okay. And we plot -3. So this one's really 3.5. When you think about it. Okay. So this thing isn't perfectly symmetrical across the y-axis, but that doesn't matter on this particular problem. Now, the fact that it says that its values below all of this equation, below the x-axis, not including the x-axis, is what that statement means. So all of this stuff down here, but not the x-axis itself. So I go from here, -3, non-included, because the -3 is on the axis, all the way over to 7/2, which is also on the axis, so I do not include it. So this would be your interval notation answer. That would be your graph answer. Except it really shouldn't be, that yellow shouldn't be above the line. Well, after I did it accidentally, it was too late to erase it. Okay, question on this one? This, if you get the equation and you get 0 on one side, that's what that first step of those rules said. Get the equation so you got a 0 on one side. Then you can have your symbol, and it tells you what part, above or below the axis, you're looking for. Okay? It escaped. Okay, what about this one? Well, we're going to skip over that one and go to this one. Look at this one. This one's already got an equation form. Happens to be a second degree, so it's a parabola. Happens to be positive, so it opens up. Y-intercept is 25. Now, we factor this thing, and it becomes that when you factor it. That means we've got a touch and go point. Where is this touch and go point? Well, it's at 5/2 or 2.5. Move the 5 over, divide by 2. Okay. So here, instead of 3.5, we now have 5/2 or 2.5. Okay. So we got our parabola drawn. Now the question is, what part counts? Well, in this case, it's a less than or equal, so anything on the axis is included. Anything above the axis is excluded. Because this says stuff lower than 0. Or negative of 0. So the only answer to this actually is this column. Because none of that up there is included in that less than or equal, except that one point right there where it touches because of the equality. Okay. So in other words, it touches only at y=0. So here's our solution, like I said. You could either write it this way or that. This way is good enough for me. That way, probably how Alex wants it. Okay. What's the difference in this one and the previous one? We dropped the or equal. So in this case, it's never negative. And it's never zero because the inclusive is not there. So the answer here is empty set or no solution. Because there is nothing in this graph that is below the line, is what that's saying. Question?
Yeah.
You sure?
Yeah.
Okay. Did she have a question?
No.
Okay. What's the difference on this one? Same equation, except I flipped it to be greater than or equal this time. Okay, we go through all the same factoring stuff and all of that. But in this case, we want to know what parts of this are either on the line or above the line, is what this is saying. Well, all of it. Everything from the farthest value that way to the farthest value that way. So the answer then is negative to positive infinity. And we don't have time to go through those. So, well, here's number A. This is number A right here. Number A factors into this. Okay? So we got a touch and go point right there at 1/5. Now, based on this symbol on A, what part is going to be included? Well, it can't include the point on the line. And it can't include anything above because this says littler than. So the answer on this one is also going to be no solution, empty set. Let's go to this one. Again, a quadratic. Here's my y-intercept up here at 5. Okay. And in this, that thing right there factors. And I get the values here and here. Okay. Obviously a 1 and a 5. Okay, you just got to watch yourself. They're both going to be a positive 1 and a positive 5 based on rule of signs. So here's the 1 and the 5. But this does not include those points. Those actual points on the line are excluded. And only the portion of this graph that is below the line is included. Okay, so what is your answer then? Notation 1 to 5, both of them non-inclusive. Let me know when it's safe. Okay. What did I do? Different equation this time. Okay. Well, actually, we're going to get 1 and 5 again, here and here. Sign changed. Now, what is above the line? Because there is no or equal, these 2 points are excluded, but it's everything this way from there. So we're going to have a union. This stuff, whereas this keeps going this way, and this stuff where it keeps going that way. Okay. Notation then would be this. I've got a split value, this part and that part. And that's the difference that this sign made here. Okay, different equation this time. We wore out the old one. Greater than. That means above the y, above the x-axis. Okay. Well, number 2 is they switched it to less than. So they're using the same question with 2 problems. Once when it's above. When it's above, you can figure out, in this case, the answers are going to be 1 and 4, positive 1 and negative 4. based on factoring that. Okay, that being the arithmetic to go with number one and number two actually. Okay. So in this case, where it's greater than, like the last, it's everything above here, but it does not include those 2 points. So therefore, here is your interval notation. Okay, another problem. Take the 6 over. Here's my y-intercept down here at -6. Factor this thing. Okay, and you get the values of -3 and +2. Now this time, again, the x-axis is not included. So these two right here are non-inclusive points, forcing me to have a union interval for the 2 different ranges. Okay. Good morning. Okay, any questions on this? We're starting to become repetitive, aren't we? Right. I don't think I wrote anything on this one. Polynomial. Well, this one actually is a rocket blast. Anytime you see a t-squared, that's a gravity problem. What goes up must come down. Okay, we're actually going to skip through this one. Okay, gravity is 32 feet per second. Velocity is 64 feet per second. And starting height is 1 foot is what that's saying. That's what that notation is. This is basically one of those problems like in the movie, what is it, Vanilla Sky or October Sky. Vanilla Sky is a totally different movie. October Sky, where the kids were launching rockets for a science fair thing. Okay, now we're done.